weight required to switch the same type of power levels. However, the gate drive circuits required and the power required to turn them on and off were somewhat substantial, and it still took up some volume. Later on, IGBTs came along. Gate drive requirements are a lot less demanding, and switching frequencies can go up, and you can achieve some gains in the higher frequency operation of the IGBTs. And what we're looking at in the power electronic building block is to achieve even greater size and weight reductions and reductions in cost through the development of a power electronic building block. Now, the power electronic building block, when we get done, will hopefully include all the power switching components, the gate drive circuits, the gate drive power supplies, sensing circuitry, and even to some degree, even some of the control circuitry required. And this building block should have both military and commercial applications, and hence, if produced in large volumes, should be a very low cost item, or a lower cost item for the future. What we have here, this is the power electronic building block PEP0 that's currently being developed by Harris. What we have here is the main power switching unit. It uses MCTs for the power conduction. The gate drive circuit, which is shown here, is currently on the outside of the unit. Hopefully it'll be incorporated in the PEP1 design or the PEP2 design, but currently it's on the outside. And we also have a water-cooled heat sink here that will be used in conjunction with the MCT with the power electronic building block to maintain, to extract the heat from the unit. The MCT itself, the electronic components, the electronic components in the MCT are actually segregated from and isolated from the water that's used to cool the device, so you do not have to use deionized water in this particular instance. Okay. This is the PEP1 module currently being developed by Harris. This is the current water-cooled heat sink that's associated with cooling the Harris power module. The gate drive circuit used to turn on and off the components in the power module. Back in the early 60s and 70s, the power semiconductors used aboard ship and Navy equipment required a large volume, and they were of substantial weight. Over the years, through the development of the power equipment aboard the ship, this power electronic building block program is aimed at reducing even further, actually for a matter of factor of 100 to 1 from what we had in the 60s to a small unit that has all the power control components, the control circuitries, the gate drive circuitries, the gate drive power supplies, all in a very small volume and weight. Block PEP1 that's currently being developed by Harris. This is the primary module that has the MCTs, which are low power dissipating devices. This is a gate drive circuit that's associated with turning off the power switching components in the module. In further PEP electronic building block development modules, eventually the gate drive circuit will be incorporated in the PEP module itself, reducing wiring requirements and such, as well as control circuitry and power supplies for this gate drive circuitry, all eventually hopefully will be located within the power module itself. Under the Power Electronic Building Block program, we've developed a control algorithm for ultimate use with the Power Electronic Building Blocks. And a PEB 0 design is what we have here. We have a DC to AC inverter. What we're using right now, because the power modules are currently under development by Harris, we're using IGBTs, but ultimately we'll be using the same control algorithms that we're using in this little demo here in the Harris PEB modules. Eventually, PEB modules, we'd like to incorporate as much of the components as you see here on these individual modules into that small PEB module that we have here. And that way we can achieve some significant downsizing. Again, we have an AC output waveform that's generated through a control algorithm. We here at the laboratory have developed the resonant inductors that operate with this unit. We've developed the gate drive boards that are used to turn on and off the devices that are here. And we've also developed the resonant circuitry, which is comprises the resonant inductor and these capacitors that are high frequency, high current devices.